All right, so let me just, I'll start this up. Okay, so in this problem, we're trying to determine the surface temperature at the sun, but that comes from the radiance equation. But there are two actual radiance equations. One is J sun, or Js, is Ps over 4 pi r squared. And J is the radiance, so how much heat is coming off of that body. And then they give us the intensity at the Earth, but the intensity of the Earth also is the power coming from the sun times 4 pi r squared. So capital R squared, this R here is the radius of the body. This R here is the distance between the two objects. So they are two different things. So what we're going to need to do is solve both these equations for PS and just set them equal to each other. So if we do that, you get PS equals 4 pi capital R squared JS, but that's going to equal 4 pi lowercase r squared PS. And then what we can do is note 4 pi, we can cancel out, okay? So essentially we're just not worried about that PS part, and we're going to be able to cancel out the 4 pi's because they're on opposite sides of the equal sign. So on the left side, we have r squared JS. On the right-hand side, we have r squared PS. Remember, these r's are different. One is the radius of the body, the other is the distance between the two objects. So now we have to do is solve this for JS, okay, and that's going to give us lowercase r squared PS over capital R squared. Sorry, no, that's not PS, it's IE. Sorry, it should be an IE, so the intensity at Earth, right, which is something that they give us. So now we just plug in the values. So it's 1.5 times 10 to the 11th squared, right? So that's the distance between the sun and the Earth times 1400 divided by the radius of the sun. So they tell you 696 million meters. So 696 times 10 to the 6. And so JS, so the amount of radiation emitted by the sun is equal to 6.50 times 10 to the 7th watts. That is not our answer, but that's going to help us get to our answer because that equation or that number is going to be equal to the formula, the radiance formula, which is emissivity times sigma, which is that Stefan Boltzmann constant, times t to the fourth. And then here's what we're solving for. So you got to be careful because you're going to take a fourth root. So if we do some algebra, it's going to be t equals the fourth root of JS over emissivity sigma. Now they tell us to treat the sun as a true black body. So that tells us that the emissivity is 1. So it's like we don't have to worry about that part. So we're just doing JS over sigma. Okay, so JS is that 6.50 times 10 to the 7th number. Sigma is the constant, 5.67 times 10 to the negative 8th. Okay, and when we take this, we do plug this into our calculator. So remember, you have a couple options for the fourth root. You can do a button that looks like x to the y, but you have to remember if you plug that in, the root is 1/4, or there should be a button that looks like x, something that looks like this. If it's not a button that's in the math function, I'll figure out what it is. I just don't have my calculator in front of me because I'm doing all the answers off of the filled out note sheet. Okay, so when I do that calculation, it's 5,820 Kelvin, but they may ask for in Celsius. So all we're going to do is subtract out that 273 and get 5,547 degrees Celsius.